Hello, everyone. Welcome to another episode of Scala Space Podcast. I'm Łukasz Biały, your host, and today with me is Billy Autrey, implementation engineer at Engflow, a longtime Scala consultant and ex-Lightband employee, also a sitting member at the steering committee of Play Framework. So today we are going to talk about compiling Scala, and specifically compiling Scala at scale. Compiling Scala has been a major irksome problem space for many projects, many companies. We've seen the compiler itself getting some very good speedups over the years. We've seen some additional tech being created around the compiler, like Zinc, the incremental compiler for Scala. We've seen compilation servers like Bloop being created. But then there's something completely different in this area, and that thing is Bazel. Billy, could you tell us something about Bazel?
Right, yeah, sure. So Bazel, if you haven't heard of it, is an open source project. It originated as a build tool inside Google called Blaze. Google uses Blaze to manage their very large monorepo and to provide a good developer experience and unify the tooling experience so that their tooling team can kind of focus on one thing and pay that cost to everyone. Bazel also includes, kind of in true Google form, there's Google's, everything if you think about Google is centered around this idea of how do I take pieces of execution and break it down into smaller pieces and then push it out to commodity hardware so that I can, benefit from parallelism of having a lot of cheap execution. And this, of course, extends really nicely into the cloud. And Google's no exception here with Bazel. What they do internally with Blaze is they have a system called Forge, which is very similar to what Engflow provides. And all it really is a remote execution platform that provides small blocks that you can send, execution blocks to, and it will build all of those components in parallel. Bazel is polyglot, so you can make it work with any language. So there's support out of the box for C++ and Java, and there's a bunch of extensions that are built for a myriad of languages. Scala is one of the main ones that is used heavily. I believe it's used heavily inside Google from what I could tell, because it's part of the main Bazel build repo right now. But I know that there's big support for Python. There's some support for Rust, TypeScript. Any language that you can think of, there is probably a Bazel rule set for it, because it's totally extensible with a Python-like language called Starlark. So that's sort of Bazel in a nutshell. It's very much built to help you manage builds, give you the ability to remotely execute and remotely cache things. One other thing about Bazel that's really interesting is Bazel takes everything as an input, right? It takes all of your input files, but it also takes your actual tool chains, the things that you use to actually compile. Those are inputs, and the flags that you use as well to any options that you might have that might change the build. All of those are considered as inputs, and Bazel to determine correctness just generates a hash to say, okay, this is my input hash. And so the more hermetic you are, the more things that you include as inputs, the more deterministic your build is. And so Bazel really, this kind of plays into the whole remote caching idea. The more hermetic it is, the more that you can say, okay, this is exactly the same build with exactly the same inputs because my hash matches exactly. And if that's true, then you can go and get that, the artifact that was built for that by anybody and use it as a drop-in replacement for that, jar, maybe, using Scala as an example. So if somebody else built a jar on their computer and their hash key is exactly the same as mine, that means I can take whatever jar they compiled, pull it down from a remote repository, and sort of like share the compilation time and the CI compilation cache all across my build organization and not have to build anything. Because ultimately, the fastest build is the one you don't have to do.
Oh, definitely. So where does Engflow fit into this puzzle, actually?
Yeah, I mentioned it briefly earlier, but Engflow is a bit like Forge. The idea is that a lot of build tools Bazel has a remote API repository. It's a gRPC protocol that takes very specific instructions, like here, what cache capabilities do you have? What do you have this cache key? Remotely execute this, or I want to upload this blob so you can remotely execute something. That whole API is implemented by Bazel. It's also implemented by Buck2. Pants, I believe, implemented it. SPT is starting to implement the remote cache API. But what Engflow does is it implements the server part of that API, and it will actually do the remote execution for you. So if you want just a remote cache, Engflow can do that. We can take cache hits and sort of use it as the source of truth, or the system of record for your builds. So CI stores that information, and then local developers can benefit from that cache. But we can also remotely execute build components. So the subcomponent, the smallest component of a build in Bazel is called a target. And you can have targets down to the package level if you want, even in Scala. And so all of those little packages, all the subcomponents of a full Scala jar can be farmed out to Engflow, and we'll compile them on the farm massively parallel and improve build times. We can talk about it a little bit later. I think it's in the script later, but there's some pretty good testimonials from some of our customers. Some are public, some are not, but we get pretty impressive build improvements by parallelizing on the cloud. And we're also cheaper than most people can run it on their own as well.
Okay. Could you tell me, I assume that you have to have some specific configuration, some specific extensions for Bazel to work with Scala. Are you aware that, does everything work with Bazel? Like, is the same set of expectations that we can have with SBT, would it fit to what you get with Bazel?
There are some limitations here and there. Bazel, because you have to have your inputs declared explicitly, it means you have to have all your inputs declared explicitly. And so I'll probably talk about this later, but transitivity is a little tricky with Bazel. You have to declare all your inputs. There is a rules Scala extension. It was originally created by Wix, and it's open source now. Lots of people kind of contribute to it. In fact, Mike Bland from Engflow is helping to contribute to it to make it work with Bazel mod, for those of you who know who that is. But rules Scala, it does work with Scala test and spec 2. It does work with there's a host of different tools. It did not work with S coverage though, because Bazel expects to use its underlying Java Jacoco for coverage. So if you run coverage with Bazel, you're going to get Jacoco results. So that might be a little bit of a gotcha there. Essentially, if there's an SPT plugin,
does Jacoco work with Scala at all?
It does, yes. I actually have some PRs to fix a few things here and there in rules Scala. So it's not the best experience, but it is being improved and fixed by people that do depend on it today. So, but it does work. It works pretty well. There's some gotchas here and there because the Jacoco has to work with the instrumented Java code or the Java bytecode that gets compiled from the Scala, and sometimes that expanded bytecode can be tricky once you add the Jacoco instrumentation. So if you have like really, really big ADTs, for instance, with lots and lots of types, it puts all those in an object, and then when you instrument that with Jacoco, you might actually hit the Java function size limit.
Oh.
So there's little gotchas here and there that you have to kind of reason about and break down your Scala classes if they get pretty big, which is something you kind of see sometimes in monorepo Scala with really big monoliths or big monorepos. But breaking down those things is something you should probably want to do anyway.
Okay. So, you mentioned that Bazel wasn't built with compiling Scala in mind. I guess the original code bases at Google, they also have their own problems, I would say. I'm not a C++ engineer, and my experience with that is quite limited. But from what I know, the builds for C++ are also kind of heavy, kind of slow. Bazel helps with that also, right?
Right, right. We have a number of customers, and there's many examples out there of people who have gotten impressive build speed improvements with C++. Um, the toolchain story is still evolving there, including hermetic toolchains to make your C++ builds more portable is still kind of an evolving story. And then if you're building from a M2 Mac onto a Linux machine, it's called cross-building. That can be fraught with issues, is because it's looking for, local things if you don't know which flags to include. So there are some gotchas there on doing remote execution with C++, but because of the remote caching capability and the way that sandboxing kind of works and the improvements you get with the way that Bazel kind of structures builds, people have seen dramatic improvements. Another use case that we see quite a bit is people generating custom code or generating headers, things like that. Any sort of generated code or layers of codes, dependencies that, or layers of compilation that have to happen work really well with Bazel because it's very good at detecting which things actually changed and which things have not. Whereas if you're using something like make, it may falsely assume that something has changed with your header file, for instance, if you're not doing things properly, and recompile the whole world. So I'm also not a C++ expert. I've spent some time a long time ago building Half-Life 2 mods and stuff like that in C++, but that's hard. That's pretty far from a production C++ experience. But I would say that over half of our customers that we work with at Engflow ask us about Bazel stuff every day because we have a lot of Bazel experts at Engflow, and a good portion of them are using C++, and they're very happy with it, and they're seeing amazing build improvements with it. One of our customers, so Buck 2 is very similar in some regards than to Bazel. In fact, it's kind of built to drop in on top of your Bazel build structure, so you can use the same build files. We have one customer that's using Buck 2, and they said they got like a 30 to 40% improvements in build times with C++.
Sure, Bill, but what is Buck 2, by the way? I don't think our audience knows that.
Yeah, so Buck 2, if you're not familiar, is a build tool that was inspired heavily by Bazel. It's built by Meta. I believe Meta is still in the process of migrating to it, but it implements build files using Starlark, the same language that Bazel uses. It also uses the same remote APIs as Bazel, so you can use Buck 2 with Engflow or any other remote cache or remote execution platform. But it's built, I believe, in Rust, so it tries to be like more bare metal, a little faster, and it also doesn't have. Bazel was originally built for Google and C++ and Java, so those are included. Those rules are. Buck 2 tries to not make any assumptions about what you're doing, and everything is an external rule set. Mm-hmm. It's a very green project. It's very new. I think it has some promise, but I think the community needs to grow before it can be really adopted by lots of customers. But it's gaining a lot of popularity from what I can tell, and is I would think of Bazel and Buck 2 sort of interchangeably. The only thing I would compare is the remote execution experience and the developer experience and the support experience, because there's a lot more knowledge out there for Bazel. But I would consider them kind of like cousins as far as build tools go.
Or competitors. I assume that you mentioned that it's a green project. I guess that there is no support for Scala yet in Buck 2?
I don't actually know if there is or not. I know that you can't just drop in the Bazel rule set. It doesn't work like that. And so I would probably say that the most common thing that I see with Buck 2 is Rust. People trying to do Rust. And so I imagine that most of the people who moved on from Scala to Rust are maybe not interested in building real Scala support for Buck 2. But yeah, that's something for me to look up later, I guess.
Okay, I mentioned C++ kind of on purpose here, because Scala has grown to be a multi-platform language over the years, and I have to say I'm quite thrilled about Scala native. Scala.js is awesome, obviously. I love it very much. but I have a special place in my heart for Scala native with actual Go-like static binaries that you can get. So I was wondering if you happen to know anything about support for something like that, for Scala being a cross-platform language with native extensions. Would it be possible to build a project that builds into a native binary via Scala native with Bazel right now?
I don't know if a rule set exists off the top of my head for that exact use case. But thinking about how it sort of works, I imagine it should not be very difficult to do that. I think you would have to use Rule Scala. I'm pretty sure Rule Scala does not support Scala native out of the box, but it would be pretty easy for you to just so you would have to invoke the Scala native compiler on top of things, and you'd have to potentially build a rule set or some simple rules to kind of invoke those things. But it would not. It's so you might have to do a little bit of hand building if it doesn't already exist. I would honestly be surprised if it didn't already exist, though, because Scala native has been around for a while, and Rule Scala has been around for a while. And there's, for instance, there's play rules out there. There's some Bazel stuff going on out there. There's a myriad of support for many Scala things in Rule Scala. So even though it may not support Scala native directly, I'm sure somebody has like a drop-in rule set for that. And if not, come talk to me and we can, make it happen, I guess, if you're watching this.
Cool. I was just thinking, purely hypothetically, because you mentioned that you can provide multiple different dependencies. The problematic case, I think, for Scala native itself would be that you have to have correct dev versions of artifacts, binaries. So, SO files, basically. So you have to have them present on the system. I think given that, we talked about compiling C++, there should be something that would allow you to declare those things as inputs, or not. I'm completely green. I have no idea what I'm talking about, but I would imagine it should be possible to just declare, okay, this is a Scala program, but to build it, we have to have those, DLLs.
Yeah. So what you would probably do is, Scala native is the thing that actually has to reconcile your SOs or your DLL files, those libraries. And so you can, the way that Scala sort of works with, not Scala, the way Bazel works with regards to all of that is that everything goes into a sandbox. And Bazel pretends that nothing exists outside of the sandbox as much as possible. And so the more that you can sort of declare, okay, these are the inputs that go into this, and here's the location where they are as dependencies in your build file, then Bazel will copy those files into the sandbox at specific locations so that you can link them appropriately. So that's sort of how you should think about that. That's ideally you would fetch those dependencies externally somewhere, so that you can transport your Bazel build. But I have seen people do it where you have to build it on a certain kind of machine, and it expects it to be in certain locations, or maybe put it in a certain location in a Docker container so that you're always transporting the container. But yeah, that expecting your libraries in a certain place, or including them as inputs, is kind of necessary, because then you don't end up with we call that a hermeticity leak in Bazel. If you're not hermetic, and you're expecting things to be in the file system, that's a leak, and that can cause non-determinism. So it's actually kind of an anti-pattern. You want to try to prevent that as much as possible with the way that you're specifying your C++ libraries. And so as long as you include them as inputs, they get copied into the sandbox, they get linked properly, and that should be fully transportable depending on how you set all that up.
Cool. That kind of sounds like pure functional programming. You only use your inputs, so the model seems to be quite fitting to Scala developers. Okay, so I wanted to ask you about if you have any insight into what are the actual gains. So, like, let's say a company decides to adopt Bazel. And I'm not sure because, when talking about those companies that are doing huge scale of software engineering, they, I think, usually have something homegrown in this area. So do you happen to know of any company that would migrate from something that isn't built, from ground up to deal with monorepos that are huge, that adopted Bazel, and what was the outcome for them?
Right. So I will say that I have worked with very few companies that were not already in progress in their move from SVT or Maven to Bazel. I am aware that Wix has a blog entry out there, though. Wix is actually one of our customers, by the way. But Wix has published that their move from Maven to Bazel and from polyrepo into monorepo, which I believe is still in progress based on their blogs. But those moves have given them like a 10x boost in CI times and build times. So that's pretty impressive.
Yeah.
I do know that like you can go to Rule Scala and you can see a list of lots of folks that are using Rule Scala and using Bazel, which means they moved on from either Maven or SVT. And they have seen tremendous gains because they're still using it today, as far as I know. I know Lucid, for instance, has pretty famously used Play plus Scala. I think they were one of the providers for a Play framework Bazel rule set. Let's see who else is on that list. I think Gemini is on that list. Just pulling up the blog post right, or the so if you go to Rule Scala and you scroll to the bottom of their README, there's an adopters section. It lists Canva, Domino Data Lab, I've not heard of. It lists Etsy. It lists Meetup and Spotify and Stripe, Twitter. Yeah, I do know, for instance, Twitter. So Eugene Yokota, who obviously is a pretty big name in the Scala space, he worked at Twitter for a while, and he's got a talk actually at one of the Bazel cons where he talks about his experience sort of moving from Pants to Bazel and adding a plugin to kind of support a feature that was present in Pants but missing in Bazel for multiple versions of things. That was a need inside of Twitter. So that's a pretty famous example of somebody having something that they wanted to do in the build that was not present, and they just built it for Bazel. There's so Li Hoi, who is also another famous name in the Scala space. I do know for a fact that he gave a talk at BazelCon as well. So Databricks is where he was working at the time, and he was talking about support for multiple Scala versions, and he talked about their DevBox experience and how they sort of do Bazel builds and how they reconcile their monorepo. And so those are big companies with lots of smart people that are clearly using Bazel with Scala and see major benefits from it. So I don't have numbers on all those companies, unfortunately, because they don't talk about their major benefits there. But it's clear to see that they're seeing major benefits from not having to wrangle single build files. And I do know that one of the reasons that this is possible is, one, because of remote caching. It's like I said before, it's much faster to not build something you're aware of, and Scala greatly can benefit from that because of the JVM. But the other thing that's really interesting is that Bazel, the best practice in Bazel is to break up your builds by package. Whereas if you think about what you do with SVT or with Maven, what you typically do there is you have like a POM file for a major block or component or a jar. So you might have a jar that's, my database jar, and your database jar might have, hundreds of packages to deal with all of the different ORM things you're doing and all of the different data packages you're dealing with. And then you might have, 5 or 6 components to deal with different databases. And those are all different jars, and they may have tons of packages as well. And so what Bazel does is it allows you to say, instead of building the whole hundreds of packages database jar, what I can do instead is I can just build I can just build each component and have a build file for each component that I'm using, and each of those components can be built, and be cached independently, so that you can kind of break up your big jar or your your SPT project into lots and lots of little projects that can then be remotely executed, remotely cached, and you don't blow up your entire build graph every time you change the commons library out from under it. So I guess that's a long hand-wavy way of saying there's very few numbers out there for this exact thing, but because I think it's a sign that big companies are doing this, and I can imagine, based on what I know about Bazel, exactly the kinds of benefits you get from that experience.
Yeah, I just wanted to ask you about 10x. It's kind of big, and what mechanics, what magic would allow Wix to get benefits like that. But once you describe the mechanics, I guess that's not something that you get out of the box, right? You just swap Bazel for SBT, and it just does everything faster. That would be weird, but if you actually do the thing you mentioned, if you slice your sources into very small pieces, that almost kind of sounds like parallelizing the compiler with a build tool.
Yeah, that's exactly what's happening. So Bazel, the way that it actually works, the experience of using it is that if the first time I run a command on the command line, it will start a Bazel daemon in the background it runs on Java, so it starts a JVM, and it keeps it running in the background. So when you change a build file or you change something about the build, it will have a cache of all of the analysis it's done of your build graph, and it can compare what you've got to this hash of your analysis and figure out, oh, these things changed, and redo the analysis just for those pieces that changed. So it's very quick to determine which pieces changed in which subcomponents, and then go ahead and fix that about its internal reasoning of the build. And then when you actually say, I want to Bazel builds this whole subtree, it will it deals with the state of, okay, I know these are the targets under there, and I will go ahead and start building it. And Bazel has a concept called workers. So it will start workers up, like, a configurable number of workers. I think the default is half of however many CPUs you have. So if I have a 32-core machine that I'm running on locally, and I say Bazel builds, this subtree with 100 targets in it, it will farm out that work to the 16 processors, the 16 workers running in 16 processors, and it will, crawl through that list and, determine what it needs to compile and compile it in parallel anyway. So just out of the box, Bazel will Scala see just the subcomponents that you've got in parallel, as fast as it can locally. And then, of course, if you're doing remote execution, you can crank up the job number to, hundreds, way past how many CPUs you have locally, and it'll just send it out to 100 workers on the cloud all at once and build each of those some components in parallel. So those are a couple of the big benefits, I think, of Bazel and how it sort of thinks about parallelizing.
Sure. So the whole thing with build tree and the option to split it into smaller pieces, this sounds fantastic, but I believe that in big code bases that would be a huge pain. I know that big companies like Twitter, or Google, they basically have people on payroll that their job description is build engineer, right? So maybe it's just it's maybe someone's job just to go there and create files to, okay, this small piece will compile with on its own with these dependencies, right? But it kind of begs for automation, right? Like,
right,
it's just a tree.
So there's a couple of options here on the table for this. The most popular thing I think to do is Bazel has this very famous extension called Gazelle, and Gazelle was originally written in Google for Go, and the idea here is that it will actually, out of the box comes with support for Go and a few things and a few languages, and if you have a Go code base and you say Bazel run Gazelle, it will crawl through your Go code base, figure out what the dependencies are for all of your different targets, and it will generate these build files for you with all the dependencies. generate your external dependency list and stuff like that. And so it fully automates this process of generating your entire build tree. Support for Scala is mixed. I think there's a couple of people who have attempted some Gazelle extensions for Scala. I'm not sure what state they're in right now, but I do remember when I was working closely with one customer or one employer actually, that when we looked, there wasn't anything that looked promising, and so we were talking about sort of building our own. That may have changed since, because it's a growing ecosystem. BazelCon has, I think, 500 people going to it pretty soon, and so maybe that the Scala extension exists or is in beta form or something like that, or maybe it exists and it's a little bit dead. But that is to say, I guess a long way of saying, yeah, there is automation that you can do to generate build files if you want to. Bazel won't fix a bad build graph though. So if your solution is I'm just going to generate the build graph every time and save on my developer experience, what you're essentially doing is you're trading out, for an interpreted experience of generating build files, which costs every time. Whereas you can kind of think about if you generate your build files by hand or with some basic automation and then check it in, then you are sort of caching the state of the build graph as build files in your file system, and then Bazel just has to parse those and then look for the differences. So some of that analysis and building of the build graph and in code analysis doesn't have to happen if you sort of do it yourself a bit, which can be pretty daunting for a pretty large code base. But yeah, that's what I've seen other people do sometimes as just like migrations are fundamentally about taking a big task and dividing it into small subtasks. I come from the microservice world, obviously, because I used to work at Lightbend. And so, a big pattern there is the strangler fig pattern, where, the strangler fig slowly, like it grows one little bit, and then, the other little vines slowly take over the tree that it's, taking over. And so you can think about a Bazel build that way. Like you could do what's kind of like a lift and shift, just like have build files for whatever my SPT subprojects are. And that's a very naive way. It won't get you that many benefits out of the box because you're not able to parallelize very far with your build, and the remote cache hits aren't going to be any better than you would get already with SVT. So you might not see much speed benefit if you do that, maybe a little bit. But as you start to, as you have these first few vines, you can break them down into, smaller components, smaller project builds, and peel it off that way. So, and then the other thing that I would say is, I can show this later. I have a little bit of a demo we can get to later, but there's a way to turn on transitivity with Bazel. And if you turn on transitivity, it will complain about, hey, these dependencies are explicitly in your files, but you don't have them. You should run Bulldozer to add these dependencies. And so Bazel has in its engine the ability to make recommendations about which dependencies you should add. So that's not fully automatic, but it at least gives you a hint towards what you could use to generate some automation with log outputs.
I'm kind of suspicious. Are those recommendations actually useful?
Sometimes. It's a little bit like working with AI, I guess. With AI, you ask it a question and it gives you an answer. In the answer, you should kind of squint at and make sure that it makes sense, or try it out or analyze what it's trying to tell you. So Bulldozer recommendations, I have found in the past, can sometimes be a little bit naive. So for instance, if I have this build tree, right, and I have, I need Akka and I need play JSON as dependencies, and there's some other thing like a whole play project that has both of those dependencies. Sometimes the Bazel recommendation will crawl up the tree and find that this thing has both of those in common. So you should add this as the dependency, right? Because it transitively has everything you need. But it's obviously a really bad idea to add an entire play project as a dependency for something else that may or may not actually fit. So it's definitely look and make sure that dependency makes sense, because it's very easy to blow up your build graph if you add dependencies at the wrong layer. Visibility is a really key way to make sure that you're adding dependencies in the right direction, kind of following onion architecture for your build graph as well as your actual dependencies for your code.
Yeah, I wanted to talk about developer experience now, and
Okay.
I have a surprise question actually. So it kind of the thing that you describe, recommendations for tree, you viewing the build tree. I'm already spoiling what I want to ask, but is there some graphical interface to preview the structure of how Bazel sees the world?
Yes, there is actually.
Oh,
So Bazel has this tool called Query, and every build tool kind of has this. Like SPT has the ability to reconcile your build graph and to render it, but Bazel's Query is pretty interesting because it has a whole lot of ability to, you can query what are the dependencies of this specific target, or what are the reverse dependencies in this scope, or what are the dependencies only of this kind, or what are the if I have this target and this target, what is the dependency link or chain that goes from here to here, right? So those are pretty interesting ways to kind of like wrap your head around different dependencies with the query command line interface. But I think what you're alluding to is that Query has the ability to render the entire graph out. And so I don't have the command off the top of my head, but it's actually, Engflow does a Bazel bootcamp that we give to Bazel beginners, very similar to what I've taught in the past to onboarding developers as a principal engineer. But in that training, it has an example of the query command you would generate to spit out an SVG file, and that SVG file has a very nice like visual graph of all of the dependencies in your Bazel dependency tree. So yeah, that's a very neat trick. It can be a neat trick unless your unless you go too wide with your query or your build tree is hell. But then it can be it just looks like Jackson Pollock art. It's just a mess.
well, at least you can see that you have a spaghetti on your hands, so
Yeah, for sure.
it sounds useful anyway. Okay,
Yeah.
okay. So another developer experience question.
Mhm.
It sounds great. How does it work in daily job, daily life? I'm a Scala developer. I would like to see how I can use Bazel and what would that mean for my daily productivity.
Right. So do you want? I have a little bit of a toy project baking over here. Is it a good time to
Yes,
dive
exactly.
into that?
Yes.
Okay. Cool. Let me do this then. All right. So what I have done here is this is a very green project. I decided, speaking of AI, I had a little fun working with AI and saying, help me design this application that has some interesting interesting capabilities. So this project, I guess to kind of go into it very briefly, the idea here is in Bazel, you typically, because you can have multiple languages, what you typically do here is you say, okay, I want all my Scala code to be in a Scala folder, and you put your Java code in a Java folder, and your Go code in a Go folder, because otherwise you can have quickly, get out of hand with your dependency graph here. So I built this with SVT as well to kind of, so I could test it both ways.
Could you show us the build SBT, because I think it's the easiest way for Scala developer to grasp what is happening.
Yeah. So I've got the dependencies hidden over in the dependencies file. I'll probably check this code in and make it public after a little bit of cleanup and after we talk here. Yeah. But so any watchers right now who feel like they want to look at this a little more in depth, feel free to. And you can check out the dependencies if you want. But the idea here is just that I have two projects. And the projects are looking at the weather API clients and the weather data folders for their different dependencies. And then this, I didn't name these very well here, but weather API clients is this project, project one, and the weather data project depends on the weather API client, because the weather API client has a data class in it. I didn't think through this design of the application very much. I just wanted something that had some interdependencies, and so I asked, Google's Gemini to design something for me, and this is what I came up with. So maybe if I were designing it, I probably would extract the data into a separate project itself as well. But here we are.
Okay.
And so obviously, since this is SPT and Bazel. I've got my source.
Okay.
I've got but it's hidden here because of reasons. But it's source main Scala here, right? There's source main Scala weather client is the name of this directory tree. Weather.client is obviously my Scala package. And I've actually imported this using Bazel. So there's a little Bazel button here because I didn't import this SVT file for IntelliJ to use. I just imported.
Okay, so at least you're not cheating here.
Yeah, exactly. Yeah. So in what's going on with the code itself, so this API key, I'm going to delete it after this. So nobody get really tricksy and blow up my one weather map account that I care so much about. Yeah. But the idea here is pretty simple. It's just like going to this API and it's getting the weather, right? I'm actually not a cats person. This is generated. This is what Gemini recommended to me. So it's kind of funny for me to dip into some cats here. I haven't spent that much time with it, so it's seriously in HTTP for S. But yeah, there's nothing really magical going on here. It's just going to the URL and it's getting it and it's munging that data into a weather data JSON format. And this is the weather data format. It's not too exciting. I did add a little bit of a function to this case class to convert this API will give you the data for the temperature in Kelvin, funnily enough. Anyway, so I just have a little function to turn this into the Fahrenheit temperature. And then the weather data is not doing much interesting either. It's just a repository, and it's just storing stuff in H2. Probably one of the things I'll do before I'm done checking this in is I'll add a third component that actually stores all the data in here. But this is the second bit of plumbing where we're storing the data in memory in H2. Just storing, as an ID and the key, you look up things by zip code and you get the temperature. You store the temperature, and then this in the data structure is actually the condition. Okay. So that's the sort of structure of the actual application itself. The way that Bazel kind of works in the mix here is Rules Scala does not yet support Bazel mod. I guess for people who are new to Bazel, what's happening is that Bazel traditionally has a thing called a workspace file, which is this really big, it actually looks a bit like this. It's this really big list of imports, and you download HTTP archives at specific locations. And so typically what you have here is HTTP archive, you use URLs and you download, based on that hash, a whole, tar-gz of an outside Bazel rule repository. And then you declare functions to kind of add layers okay, now that you downloaded Rules Scala, go and download its dependencies and set up its toolchains. Now that you downloaded Rules Proto, set up its dependencies and its toolchains. So that's what a workspace file looks like. Google has moved to something called Bazel mod since Bazel 7. And the idea here is that as much as possible, instead of downloading the whole HTTP archive from GitHub or anywhere, and then taking that thing and having to execute all of its methods to download its transitive dependencies, Bazel mod just allows you to have a Bazel dep function invocation here. Okay. And you can specify the name of the dependency you want, the version, and it will do all this automatically for you based on how the rule is set up. So the experience is if you're using Bazel mod well, and how I'm going to use it for our developer productivity experts course at Engflow, it should just look like this. You'll just have a series of Bazel deps, and then there will be a lock file that has all of your transitive dependencies for Bazel mod. Yeah. Okay. So that's Bazel mod, just in a nutshell. So, but you don't have to worry too much about this. Usually, this is stuff you only have to do once. Probably the most interesting thing here, though, is I'm using Rules JVM external to do Maven fetches of artifacts. And so this could probably be extracted out into another file. I haven't done that, but here all I'm doing is I'm saying, okay, this is the Mavenish string to go and download my dependencies that I actually care about. So these are all my external dependencies. You'll notice this list is pretty huge. Normally in SVT, you might only have a few things, but this list is pretty huge. And the reason for this is that I mentioned this earlier with C++. When you have, SO files or things that you depend on, you have to have all of those because Bazel will copy all of those into the sandbox. And so if you don't declare it, Bazel pretends not to know about it, and even if it knows it's in scope. And so you have to, as much as possible, include the transitive dependencies pretty far down, actually. There is a little bit of a trick. So in my build folder, I have a tool chain here. You can declare a Scala tool chain that is based on the default tool chain, and you can set dependency mode equals transitive, and that will get you some transitivity. And this is actually what I did to tell Bazel, hey, I need these transitive depths, and then it started complaining about, hey, you're missing this dependency, you're missing Scala Lang, even though you're using Scala Lang Future, is one example. So it recommended use, bulldozer, add dependency, Scala Lang to this file. And so I use that, and that's actually why I have Scala Lang in my weather API client class.
Okay.
So I know I danced around quite a bit, but yeah. So the main thing is this. This is where you declare your Maven dependencies, and this is for the whole build. This is just making the Bazel build graph aware that these dependencies should be downloaded. And this also has a concept of a lock file based on how rules JVM external works. So it has like, okay, these are all the dependencies and the SHA sums and everything, and so that you can be secure and not have like, dependency injection happening if the thing that you downloaded doesn't actually match the hash that it expects. This is a build file. What's going on here is at the top, we're saying, okay, from rules Scala, I want to import the scala.bzl rule set, and I want to specifically impart in this build file the ability to call Scala binary, Scala library, and Scala test. Okay. So this is like importing functions to say, okay, I want to be able to declare a Scala test. I want to be able to declare a Scala library. And these things are documented in rules Scala, but this is how you declare, like, I want to build have a Scala building block that compiles with Scala C, or that runs with Scala test. So this is how you do that, is you import the rule first, and then you call it like a function. Mm-hmm. I mentioned Starlark earlier. I mentioned that it's a dialect of Python. And what we're doing here is essentially calling a function called Scala binary, and the attributes are the parameters that you provide to tell it this is how you should do all these things. So in this, the only real things you have to have, so for Scala binary, everything has to have a name first and foremost, and this name is what gets you the label for what you're trying to do. You declare the source file, so the things you're actually trying to compile. For Scala binary, you have to tell it what is the actual class path to the main class. And then for the dependency list, you have to add all of your external dependencies. And then this colon is a shortcut to, in the current package, there's a library or a target called weather data.
So that's like a module dependency in SBD.
Yeah, exactly. Yeah, it's a module dependency, but you can be as granular as you want. So what's interesting here is I actually have one target for this API client, which is my object that actually executes the code. And then I have a separate project for the data itself. So I don't know if this is good or bad, but you can get kind of messy with how you structure your files in packages, because at a package level, you can declare dependencies as granular as you want. You can declare a target for every file if you want, okay, or you can separate out your, I mentioned this earlier, but if I were designing this from scratch, I would have the data package, the data file in a separate package, and it would have its own build.bazel file. But, instead of doing that, the shortcut I took here was just to have it in the same package, and I just declared a separate library for the weather data. So Bazel will know that these are different targets, and it can build a build graph based on that, so that I get, more building blocks essentially to be able to Scala compile much more granularly.
Okay.
Yeah.
Okay, so let's I'll get back to to how the definition looks like, because it mm-hmm. looks kind of arbitrary to me. But yeah, we'll get back to that. I wanted to see what happens if you actually edit code, because that's all very nice and informative, but in the end, we want to use IDE. That's IntelliJ IDEA, by the way, right?
Yes, this is IntelliJ.
Yeah.
Correct.
To write code, what happens? Do you get all the support of the IDE that you would usually get with SBT?
Right. Okay. Yeah. So let's add another function here to this case class. This is going to generate more in the build graph. So I'm just going to add, well, we don't have to do that because I've got this Kelvin to Fahrenheit. Oh, yeah, we can do this. Step fields in F. Right? Mm-hmm. So you can see it's doing some recommendations already. So, you know, the tooltips are working. This dot feels like. So you can see that the IDE's recommendations are all working. As I type, it tries to fill in. Here it's telling me, hey, you've got this declaration, it's never used. So the full IDE support is working out of the box, right? Mm-hmm. And this is just with, like, I'll show you syncing here in a minute, but this is just with the syncing information that it's got. Essentially using Bazel as a build server. It has done all this indexing, and sure. It's, you know, this is based on the indexing it already knows about.
Sure, Billy, just one quick question, both for me and viewers. You are seeing the tooltip window with recommendations with auto-completion, right?
Yes, I am.
Oh, so
I guess we can't see them.
It's an artifact of how you are sharing your screen that we can't see them. But yeah, given on how you autocomplete with tab, I assume that that's what's happening. So no problem.
Yeah, exactly.
Okay, cool. So what happens if you go to the other module action? It's called action, I think.
The other action. Oh, sorry, I'm not sure what you're asking.
The weather API client it's in another module, or
this is in a different target, right?
Target, okay.
Yeah, so this is a different target. It's the same package, of course, but it's a different target.
Okay.
So I can data. So dot main dot Kelvin to Fahrenheit. Oh no, this is Kelvin to Fahrenheit. This is not the function I want. I want the feels like. Feels an F. There we go. Okay. So I've added the code to it. The reason I was able to complete is because it's giving me the tooltips and it's recommending the different functions. So here I'm just, doing some string interpolation here to say, I want to add the feels like to my report that I'm generating here. So the first thing I'm going to do is I'm going to click on sync this. There's a little thing that comes up and it says sync project with build files. Mm-hmm. So this is just running a Bazel sync. And so this is some of this. This is probably really interesting to know. It's running in shards. And so if you have a really giant build, it will actually cut this into several tasks that run with several workers. So IntelliJ's Bazel client will essentially say, okay, you have like 5,000 targets you're trying to build. So I'm going to split this up into 4 different shards, or 10 different shards with 400 targets, and sync those at once. So this is this sync here will let you essentially parallelize the analysis of your build graph, which is really nice. It's not something you get with all build tools.
Okay.
Yeah. So anyway, you can see that it's finished. It finished very quickly, and lots of stuff was already cached. See, syncing 3 of them. It only synced 3 things out of all the targets that it found. So that's pretty good. Mm-hmm. But go back to my terminal, and so what I'm doing here is I'm doing Bazel run. This / is a Bazel shortcut for the root of my workspace. And then there's this, and then here what I'm doing is I'm printing out the whole path to this code. So Scala, weather API client, source, main, Scala, weather.client or weather/client. And then in that weather/client, I'm calling the colon as a separator to say, okay, this client is the package that I'm actually looking for. And in this package, should be a target called weather API client. And so in this build file, this is that name. This is where the name comes in. The name is the target that you're sort of using here to point your invocation at a specific thing. So I'm going to run this, and it compiled, and you can see that it only compiled a few things. Normally, if you're running Bazel from the start, it has to go and do everything that's in the workspace. So it has to go and make sure that the Maven dependencies are there. It has to go and download them, make sure that everything matches what you've got in your lock files. It has to go. Sometimes it has to. If you have rules proto, it has to go and recompile protobuf, which is a little bit goofy, but it's a thing that happens in Bazel pretty often with the rule set. And so sometimes you can have like a bunch of actions that sort of run the first time. But because I have all of that cached already locally on my local disk, it just found the only pieces that it needed to, and it compiled them, and then it ran. And so you can see that I've got my feels like and my actual temperature in Little Rock are apparently very similar. So
okay,
there you go.
Okay, this looks quite promising. I have to say that I also talked around with my colleagues at VirtusLab because I was curious whether it's possible to use Bazel with metals. It turns out that it's something that is an ongoing work by our engineers, but not only by them, obviously. It's an open source effort that we are participating in. And I managed to run a repository by Riki Taniguchi, one of our engineers. I've switched to the build for that. And to my surprise, it works, but with some caveats. It's actually very, very sensitive on whether your code actually compiles. So it compiles unsafe from what I can see. I should have probably disabled Copilot so that we can see. So you can see that methods are here. I can say for each print line. Now, for some reason, I can't see run button here. So that's a bit, there's no Scala FMT, cool, just created. So that's a bit disappointing. I would like to run this class, but it doesn't seem I can. There should be a terminal somewhere here. No, let's maybe just do this. So you said it's Bazel, right? And then, am I doing this right? Bazel run. Is this possible? Oh no, can't do that. Bazel run. So the module itself is called CMD runner, perchance. Nope.
If you have, I guess a little bit of a shortcut.
Yeah.
If you have, so in your path, it's source main Scala. So you'd have to do Bazel run /source /main /Scala : whatever the name of your target is.
Could you repeat the things after //? I'm completely green here. So
I guess the full path to where your build file is. So source /main /Scala /CMD : whatever the name of your package is.
I think I didn't write this. So the name, it's here, and it's called runner. So I guess this is the thing. Oh, yeah, it's doing something. Yes, it works. So that's kind of nice. I wanted to see, because the demo itself, it has two modules, similarly to what you have just shown. There's greeting that is living in this target, and there's CMD that is living in this target. So we have import defined in CMD that we that we depend on the lib, and I guess at this particular target, the lib greeting. So I wanted to see whether it works cross modules, and it seems that it works just fine. There's just one interesting bit that I found kinda tricky to work with, but I hope this is just something that is work in progress, because as I mentioned before, it seems to me that Bazel is running the compile on every save. So if I do something like this, it still makes sense, right? Now, if we do identity function here, and I press Command S, it tells me, okay, there's a missing parameter type, right? If we go back here, this is fine. Now, if we go map A, and we try to use dot here, there's nothing. And I think it is basically just because the code doesn't compile. So the integration at the current point in time doesn't seem to reuse the previous data set like it does with a vanilla, let's say, use of metals with SBT, because it then uses the existing Scala meta files, semantic DB files. So if we do that correctly, if the code compiles, this suddenly changes everything, and well, we can say, okay, is there one that is bigger than 10? And then, well, it's a no-op. It doesn't do anything, but we can go here, and it probably should just work fine. Yeah. So it seems to work with some limitations. That's actually quite interesting that we can do this. And when I asked around, I was told that it is actually using the same integration that IntelliJ uses. There's a Bazel BSP running as a build server protocol server that is handling communication between metals and Bazel itself.
Yeah.
So I think that the same possibilities that are open to IntelliJ are also open to metals, and that's good. That's something that I would like to see more often in the tooling world. Okay, so those features, those basic code development features that you need in your daily work, addition, auto-completion, suggestions, imports, that seems to be or working or getting there, right? But I wanted to ask about more specific things. Like, you are a sitting member of the steering committee for Play framework, right? Play is very famous for having a feature that was considered unique. When I came to Scala community, that was one of the most common arguments for using Play instead of something like, let's say, Spring, that, okay, you just run it, you say SBT run, and then you get this magical auto-reload experience that if your code doesn't compile, you can see that in your browser, that, okay, there has been a problem in the build, you have to fix something here, a piece of code. There was also the magical reload, so if you change stuff, your browser refreshes. And obviously that feature was strongly bound to SBT because SBT was the default build tool for Play. I wanted to ask if things like that can be recreated with Bazel, or is this just not possible?
I think it is possible to do this. Fundamentally, what you're talking about, the dev mode in Play is an SBT plugin. It's running code that is out there. It exists. As far as I know, the existing Play framework libraries that exist for Bazel do not do this out of the box. So they're not running in this sort of way where it runs, in dev mode and is farming back out to Bazel or anything like that. So that functionality, I think, is not there. However, I will say that, the watching your file system and automatically recompiling, that's something that SBT kind of does out of the box now anyway. Like if you do tilde compile. It will, do that. It will watch your file system, and if you change something, it'll do a rebuild. And Bazel does have an equivalent. There's a library in the main Bazel builds ecosystem called iBazel, and it might be called a file watcher. I can't remember the name of the project. I'll look it up, and you can leave it in the notes after the podcast, I guess. Sure. But it's called iBazel. If you Google iBazel, you'll find it pretty quickly. And it is a file watcher that runs, and it just essentially will continually watch your file system and will run Bazel builds on the things that change after you save them. And so using iBazel, you can get that recompile magically after things change functionality. It works pretty well from what I've seen and what I've talked to people. And I think that with that, we could easily pair it with some of the other stuff that's going on with the play dev library to hook up to the browser and auto refresh and get the rest of that. I think it has to be built though. So I guess the plumbing is there, but the magic wiring needs to happen to make it all kind of work together nicely, or it needs to be, kind of documented and built that way.
Sure.
Most of the play libraries I see today right now for Bazel, they're just doing the basics. So, there's three pieces that have to happen for all your play stuff to work. You have to compile your twirl, you have to compile your routes and reverse routes file, because that routes file has to compile down to Scala at the end of the day. And so those pieces do work. I've seen people implement them with very basic rules in personal repos, and the Lucid. If you're familiar with Lucid charts, they're the ones who built the play library, and it has that functionality as well if you use their library. So
cool. So it is possible to just start with Bazel and work with Play Framework. That's quite nice. So what are we left with in terms of stuff that isn't really nice? I would say that this transitivity that you mentioned looks troublesome, to say the least. The fact that you have to declare all the dependencies, all the transitive dependencies, the things that you never think about. You just, I'm taking that library. You don't care about 10 things that it pulls into. On the other hand, it might be actually quite inspiring to see how much stuff we pull into our builds. if we are, it might be, educational. To learn just how much stuff it costs to take into the build. But is there any way to? You mentioned Gazelle, right? Is Gazelle? Right. Do you feel it's going to be possible to have the nice workflow that we have with SBD? Okay, I want to use Play, right? Mm-hmm. And there's a top-level artifact for Play that pulls a lot of stuff for you into the build. It would be nice to have workflow like that with Bazel. That okay, I want to use this thing, just import everything that it needs, everything that I need for this to compile.
There is a library out there that I have seen used. It's called Bazel Depths, and of course, YAML. Oh. It's YAML. Okay. But you declare your dependencies in YAML, and you run a Bazel command, and it will interpret that YAML and go and download the dependencies for you. And it will also go and download several of the transitive ones. So what I was doing earlier with Rules JVM external, where I was declaring everything at the root level and then going and importing it into the other build files, it removes half of that. You only have to declare the things that you care about, and you can set transitivity on it, and it will transitively download everything that it knows about that sort of, extends from the libraries that you're sort of adding. Sometimes if there's collisions, you have to pick the version or add it explicitly. So it's not, perfect, but, dealing with external dependencies is never perfect. The Bazel Depths library isn't without its warts, though. I have seen where I don't know if today's version of the IntelliJ plugin has problems with it, but I have seen where other versions of the IntelliJ plugin break with the way that it sort of deals with jars and iJars. And so sometimes if you go and look at the source code for a particular library, it's not as nice of an experience, but That aside, it is a nicer, I guess, developer experience for including an outside dependency and putting it in a file, run a command, and then it sort of works. So that is one thing that you can consider. I do want to also caveat that I added transitivity to the Scala toolchain, but I would say that if you do that, only do it temporarily. There's a +1 mode that is a little nicer to use and is not quite as dangerous as just adding full transitivity. Because I think if you add full transitivity, you can really end up with dependency loops, for instance, and Bazel does not let you have loop dependencies, right? And so you can also end up with really ugly things in your build graph. I've seen that happen where somebody had transitivity turned up for far too long, and they ended up building very like whole play libraries into very low level things. And so when you change something in it literally burned the entire build graph. And so transitivity is a double-edged sword in this way. You have to be careful with it, but you can tweak it. And my workflow would be to turn it on to make it nice, figure out what I'm missing, add those things, and then turn it back off. Yeah.
Okay. I guess it's something you get used to when working with Bazel.
Yeah.
But there are, those hard to ignore benefits like the 10x improvement in compile times and CI speeds. So just to finish our discussion gracefully, there are probably lessons learned when taking a look at the build tools built to handle monorepo scale pieces of software. Do you think there are things that we can the lessons that were learned, we can apply them to build tools that we use in our daily life outside of companies that have huge monorepos?
So the remote API that I talked about earlier is kind of a rallying point. It was originally created by Google for Bazel or for Blaze, and it's a mechanism by which they can form builds out and cache hits out. And I happen to know for a fact that there are companies out there building plugins for other tools and using this remote cache API to essentially work with, tie together your applications with an application like Engflow, so you can have remote cache with the other build tools. And I do know, for instance, I mentioned Eugene Yokota. He's obviously very big in the SVT space. I've been working with him recently, kind of helping to figure out what we need to do to get SVT2 out. And the reason that's interesting is that SVT2, Eugene has been very inspired by how Bazel does things very clearly. And he has been changing Zinc and SVT to use the same remote API. So you can, it's SVT is about to hit milestone 1 pretty soon. It's very green, and the remote cache feature is, still just like initial phase. It's very proof of concept right now. But when it comes out, in theory, the idea is that I would be able to build my thing with SVT 2.0, and if I have a remote cache set up, then if I build it again, or somebody else builds it with the same cache hit, I won't have to do that again. So essentially getting this benefit of Bazel just at the cache level to say I can share builds across different systems and not have to build things that other people have already built. And so this depending on your build graph and how many projects you are and how big they are, this can be a big game changer. I do know also, in talking to Eugene about how this works for test, for the test libraries, he built that support, and he's reaching down subjar, I believe at the class level, to actually cache things there so that you can get partial cache hits for components of your actual tests that you're running through SVT. So, this, what I was talking about, where there's no silver bullet, you can't fix a bad build graph. You can't necessarily do that, but with SVT2, there's a little glimmer of hope that we can allow the tool to subdivide that and to be smart about how it does incrementality and to incrementally cache pieces of the build automatically, because SVT knows about the whole build graph. And so SVT is learning the lessons and being inspired by these other build tools. And I think you're going to see it more and more more build tools are going to adopt the remote API and start to work with tools like Engflow to do remote cache and remote execution in the future.
Mm-hmm. That's a very optimistic note, but I have a pessimistic question at that. Am I right to assume that there is no interop, between Bazel builds and SBT2 builds? That would be absolutely awesome to see.
No, I don't think so. That in thinking about how the hashes are created, it's potentially possible, but Bazel is taking in more data than SBT does today. And so the action cache generated hashes that you get from SBT are not going to match just because they're not taking in the exact same data. And so I can only assume based on what I know about how the two different systems work that you can't do what you just described. It's an interesting thought, and I think it has some merit. It would take some work. You would have to essentially, reverse engineer out what's going on with Bazel, and also you might have to optionally provide, like, here's some Bazel flags that we supplied, that don't do anything in the SBT build, but get imported as inputs into the way that we're calculating hashes. But it's an interesting thought. I don't know that it's actually going to make it onto the roadmap, but I like the idea, and I like where your head is on this.
Mm-hmm. Well, in the end, I think that the outcome is that companies like Engflow are probably going to become useful to companies that are still using SBT2, right? Because if that's the same interface, the same API, I guess you can handle that. Is there something is there some testing happening as we speak that, is SBT2 capable to work with Engflow? Do you do something like that?
Eugene actually wrote a blog with answering this exact question. He talked about how he's implementing it, and in the list he mentions Engflow. We actually did work with Eugene on this. We supplied him the ability to download there's a my Engflow, which is just Engflow as a Docker container that you can use to kind of test things out. That's an evolving story, but he downloaded my Engflow and got a working Engflow Docker container, and then he ran SBT2's remote cache with Engflow, and it does work. He got cache hits. So it does, as soon as SBT2 comes out, it will work with Engflow. I know this for a fact because it was tested with it.
Okay, so that's a really optimistic note to end, because it means that there are massive speed-ups coming once SBT2 is out. Okay, Billy, let me quickly check if we have any questions.
Yeah.
But I don't think we do. No, we don't have any questions. Okay, so thank you so much for being our guest today, and thanks everyone for watching.